Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
An application running on a compute engine instance needs to read data from a cloud storage bucket. Your team does not allow cloud storage buckets to be globally readable and wants to ensure the principle of least privilege. Which option meets the requirement of your team? The options are: Option A, create a cloud storage ACL that allows read-only access from the compute engine instance's IP address and allows the application to read from the bucket without credentials. Option B, use a service account with read-only access to the cloud storage bucket and store the credentials to the service account in the config of the application on the compute engine instance. Option C, use a service account with read-only access to the cloud storage bucket to retrieve the credentials from the instance metadata. Option D, encrypt the data in the cloud storage bucket using Cloud KMS and allow the application to decrypt the data with the KMS key.
To arrive at the correct answer, we focus on the keywords: compute engine instance, read data from a cloud storage bucket, principle of least privilege.
The correct answer is option C. Use a service account with read-only access to the cloud storage bucket to retrieve the credentials from the instance metadata.
Why is this correct? C. The recommended approach is to attach a service account with read-only permissions to the compute engine instance. The application can securely retrieve temporary, automatically rotated credentials directly from the instance metadata server. Why are the others incorrect? A. Cloud Storage Access Control Lists, ACLs, or IAM policies do not natively support restricting bucket access based solely on IP addresses without using VPC Service Controls. B. Storing static service account keys in application configuration files creates a severe security risk and operational overhead. The metadata server avoids the need for long-lived keys. D. Encrypting data with Cloud KMS provides confidentiality for data at rest, but it does not address the authorization requirement of granting the instance permission to read from the bucket.
Your organization is transitioning to Google Cloud. You want to ensure that only trusted container images are deployed on Google Kubernetes Engine (GKE) clusters in a project. The containers must be deployed from a centrally managed container registry and signed by a trusted authority. What should you do? Choose 2. The options are: Option A, enable container threat detection in the Security Command Center (SCC) for the project. Option B, configure the Trusted Image Organization Policy constraint for the project. Option C, create a custom organization policy constraint to enforce binary authorization for Google Kubernetes Engine (GKE). Option D, enable pod security standards and set them to restricted. Option E, configure the binary authorization policy with respective attestations for the project.
To arrive at the correct answer, we focus on the keywords: only trusted container images are deployed on Google Kubernetes Engine (GKE), signed by a trusted authority.
The correct answers are option C. Create a custom organization policy constraint to enforce binary authorization for Google Kubernetes Engine (GKE). And option E. Configure the binary authorization policy with respective attestations for the project.
Why is this correct? C. Creating an organization policy constraint enforces binary authorization on GKE clusters, satisfying the requirement to ensure only trusted containers are deployed. E. Configuring the binary authorization policy with attestations verifies that images are signed by a trusted authority before they can be deployed. Why are the others incorrect? A. Container threat detection identifies runtime threats in already deployed containers, but it cannot prevent the initial deployment of untrusted or unsigned images. B. The trusted image constraint restricts which projects can host deployed images, but it cannot verify if an image is signed by a trusted authority. D. Pod security standards restrict pod privileges and capabilities within the cluster, but they do not provide controls for image signature verification or provenance.
Your team wants to limit users with administrative privileges at the organization level. Which two roles should your team restrict? Choose two. The options are: Option A, Organization Administrator. Option B, Super Admin. Option C, GKE Cluster Admin. Option D, Compute Admin. Option E, Organization Role Viewer.
To arrive at the correct answer, we focus on the keywords: administrative privileges, organization level.
The correct answers are Option A, Organization Administrator, and Option B, Super Admin.
Why is this correct? A. The Organization Administrator role provides full administrative control over all resources and policies within the organization. B. The Super Admin role in Google Workspace or Cloud Identity has complete administrative control over the entire account and organization. Why are the others incorrect? C. The GKE Cluster Admin role grants administrative control specifically over GKE clusters, not across the entire organization level. D. The Compute Admin role grants administrative control specifically over compute engine resources, not at the organization level. E. The Organization Role Viewer role provides only read-only access to view custom roles and lacks any administrative privileges.
Your company plans to move most of its IT infrastructure to Google Cloud. They want to leverage their existing on-premises Active Directory as an identity provider for Google Cloud. Which two steps should you take to integrate the company's on-premises Active Directory with Google Cloud and configure access management? Choose two. The options are: Option A, use Identity Platform to provision users and groups to Google Cloud. Option B, use Cloud Identity SAML integration to provision users and groups to Google Cloud. Option C, install Google Cloud Directory Sync and connect it to Active Directory and Cloud Identity. Option D, create Identity and Access Management (IAM) roles with permissions corresponding to each Active Directory group. Option E, create Identity and Access Management (IAM) groups with permissions corresponding to each Active Directory group.
To arrive at the correct answer, we focus on the keywords: on-premises Active Directory as an identity provider, integrate the company's on-premises Active Directory with Google Cloud, configure access management.
The correct answers are Option C, install Google Cloud Directory Sync and connect it to Active Directory and Cloud Identity. And Option D, create Identity and Access Management (IAM) roles with permissions corresponding to each Active Directory group.
Why is this correct? C. Google Cloud Directory Sync (GCDS) is the standard and required tool to securely synchronize users and groups from an on-premises Active Directory to Cloud Identity. D. After syncing the Active Directory groups to Cloud Identity, you must assign Google Cloud IAM roles to these groups to correctly configure access management. Why are the others incorrect? A. Identity Platform is a customer identity and access management (CIAM) solution for applications, not a tool for provisioning enterprise employee identities to Google Cloud. B. SAML integration provides federated authentication, single sign-on, but does not handle the automated provisioning of users and groups to Google Cloud Identity. E. Google Cloud does not have a concept of IAM groups. You manage groups in Cloud Identity or Google Workspace, and then bind IAM roles to them.
Your company is storing sensitive data in cloud storage. You want a key generated on-premises to be used in the encryption process. What should you do? The options are: Option A, use the Cloud Key Management Service to manage a data encryption key (DEK). Option B, use the Cloud Key Management Service to manage a key encryption key (KEK). Option C, use customer-supplied encryption keys to manage the data encryption key (DEK). Option D, use customer-supplied encryption keys to manage the key encryption key (KEK).
To arrive at the correct answer, we focus on the keywords, cloud storage, key generated on premises.
The correct answer is option C. Use customer-supplied encryption keys to manage the data encryption key, DK.
Why is this correct? C. Customer-supplied encryption keys, CSK, allow you to generate an encryption key on premises and provide it to cloud storage via API calls. Cloud storage uses this supplied key to manage the data encryption key, DEK, that protects your data. Why are the others incorrect? A. Cloud Key Management Service, KMS, is designed to manage key encryption keys, KEKs, not data encryption keys, DEKs. Cloud storage always generates the DEK locally. B. While Cloud KMS manages KEKs, customer-supplied encryption keys, CSK, are the native method for strictly using an on-premises key in the encryption process without persisting it in Google Cloud. D. In the context of this scenario, customer-supplied encryption keys, CSK, are used to manage the data encryption key, DK, rather than a key encryption key, KEK.
You are designing a new governance model for your organization's secrets that are stored in Secret Manager. Currently, secrets for production and non-production applications are stored and accessed using service accounts. Your proposed solution must provide granular access to secrets, give you control over the rotation schedules for the encryption keys that wrap your secrets, maintain environment separation, provide ease of management. Which approach should you take? The options are: Option A, 1. Use separate Google Cloud projects to store production and non-production secrets. 2. Enforce access control to secrets using project-level identity and access management, IAM, bindings. 3. Use customer-managed encryption keys to encrypt secrets. Option B, 1. Use a single Google Cloud project to store both production and non-production secrets. 2. Enforce access control to secrets using secret-level identity and access management, IAM, bindings. 3. Use Google-managed encryption keys to encrypt secrets. Option C, 1. Use separate Google Cloud projects to store production and non-production secrets. 2. Enforce access control to secrets using secret-level identity and access management, IAM, bindings. 3. Use Google-managed encryption keys to encrypt secrets. And the remaining options are: Option D, 1. Use a single Google Cloud project to store both production and non-production secrets. 2. Enforce access control to secrets using project-level identity and access management, IAM, bindings. 3. Use customer-managed encryption keys to encrypt secrets.
To arrive at the correct answer, we focus on the keywords, provide granular access to secrets, control over the rotation schedules for the encryption keys, maintain environment separation, provide ease of management.
The correct answer is option A, 1. Use separate Google Cloud projects to store production and non-production secrets. 2. Enforce access control to secrets using project-level identity and access management, IAM, bindings. 3. Use customer-managed encryption keys to encrypt secrets. Review the options on screen.
Why is this correct? A. Separate projects ensure environment separation. Project-level IAM bindings provide granular access while maintaining ease of management. Customer-managed encryption keys give you control over rotation schedules for the encryption keys. Why are the others incorrect? B. A single project fails to maintain environment separation. Secret-level IAM bindings reduce ease of management. Google-managed encryption keys do not provide control over rotation schedules. C. Secret-level IAM bindings create excessive overhead, violating the ease of management requirement. Google-managed encryption keys do not give you control over key rotation schedules. D. Using a single Google Cloud project fails to maintain the required environment separation between production and non-production secrets.
You discovered that sensitive personally identifiable information, PII, is being ingested to your Google Cloud environment in the daily ETL process from an on-premises environment to your BigQuery datasets. You need to redact this data to obfuscate the PII, but need to re-identify it for data analytics purposes. Which components should you use in your solution? Choose 2. The options are: Option A, Secret Manager. Option B, Cloud Key Management Service. Option C, Cloud Data Loss Prevention with Cryptographic Hashing. Option D, Cloud Data Loss Prevention with Automatic Text Redaction. Option E, Cloud Data Loss Prevention with Deterministic Encryption using AES-SIV.
To arrive at the correct answer, we focus on the keywords: sensitive personally identifiable information, PII, obfuscate the PII, re-identify it.
The correct answers are Option B, Cloud Key Management Service, and Option E, Cloud Data Loss Prevention with Deterministic Encryption using AES-SIV.
Why is this correct? B. Cloud Key Management Service provides the cryptographic keys necessary for encrypting and decrypting data, which is required for deterministic encryption and subsequent re-identification. E. Cloud Data Loss Prevention with Deterministic Encryption using AES-SIV obfuscates data consistently while retaining the ability to decrypt and re-identify it using the correct key. Why are the others incorrect? A. Secret Manager securely stores secrets like API keys and passwords. It does not provide data tokenization or encryption functions needed for re-identifying PII. C. Cryptographic hashing is a one-way function that irreversibly transforms data, making it impossible to re-identify the original PII for analytics. Why are the others incorrect? D. Automatic text redaction permanently replaces sensitive data with placeholders or masking characters, permanently destroying the original values and preventing re-identification.
Your organization must store highly sensitive data within Google Cloud. You need to design a solution that provides the strongest level of security and control. What should you do? The options are: Option A, use cloud storage with customer-supplied encryption keys, CSEK, VPC Service Controls for network isolation, and Cloud DLP for data inspection. Option B, use cloud storage with customer-managed encryption keys, CMEK, Cloud DLP for data classification, and Secret Manager for storing API access tokens. Option C, use cloud storage with client-side encryption, Cloud KMS for key management, and Cloud HSM for cryptographic operations. Option D, use cloud storage with server-side encryption, BigQuery with column-level encryption, and IAM roles for access control.
To arrive at the correct answer, we focus on the keywords: store highly sensitive data, strongest level of security and control.
The correct answer is Option C, use cloud storage with client-side encryption, Cloud KMS for key management, and Cloud HSM for cryptographic operations.
Why is this correct? C. Client-side encryption ensures data is encrypted before reaching Google. Using Cloud KMS with Cloud HSM provides hardware-backed key protection, ensuring the absolute strongest level of security and customer control over highly sensitive data. Why are the others incorrect? A. While CSEK gives you control over keys, you must still provide them to Google temporarily for encryption/decryption operations. Client-side encryption is stronger as Google never sees the keys. B. CMEK relies on software-backed keys managed within Google Cloud. It provides less absolute control and security compared to client-side encryption combined with hardware-backed key management, Cloud HSM. D. Default server-side encryption means Google completely manages the encryption keys. This offers the lowest level of customer control and does not meet the requirement for the strongest security.
You are migrating an on-premises data warehouse to BigQuery, Cloud SQL, and cloud storage. You need to configure security services in the data warehouse. Your company compliance policies mandate that the data warehouse must protect data at rest with full lifecycle management on cryptographic keys, implement a separate key management provider from data management. Provide visibility into all encryption key requests. What services should be included in the data warehouse implementation? Choose 2. The options are Option A, Customer-Managed Encryption Keys. Option B, Customer-Supplied Encryption Keys. Option C, Key Access Justifications. Option D, Access Transparency and Approval. Option E, Cloud External Key Manager.
To arrive at the correct answer, we focus on the keywords: full lifecycle management on cryptographic keys, separate key management provider from data management, visibility into all encryption key requests.
The correct answers are Option C, Key Access Justifications, and Option E, Cloud External Key Manager.
Why is this correct? C. Key Access Justifications provides visibility into every encryption key request along with a detailed justification, satisfying the need for visibility into key requests. E. Cloud External Key Manager allows using a separate, external key management provider for data encryption, satisfying the requirement to separate key and data management. Why are the others incorrect? A. Customer Managed Encryption Keys, CMEK, are managed within Google Cloud KMS, meaning the key management is not separate from the data management provider. B. Customer-supplied encryption keys, CSEK, require you to handle the key lifecycle yourself and do not provide full lifecycle management within a provider. D. Access transparency provides logs when Google personnel access data, but does not provide visibility into all encryption key requests.
You want to use the Cloud Command Line tool to authenticate using a third-party single sign-on, SSO, SAML identity provider. Which options are necessary to ensure that authentication is supported by the third-party identity provider, IDP? Choose 2. The options are Option A, SSO SAML as a third-party IDP. Option B, Identity Platform. Option C, OpenID Connect. Option D, Identity-Aware Proxy. Option E, Cloud Identity.
To arrive at the correct answer, we focus on the keywords: Cloud Command Line Tool, authenticate using a third-party single sign-on, SSO, SAML identity provider, supported by the third-party identity provider, IDP.
The correct answers are Option A, SSO SAML as a third-party IDP, and Option E, Cloud Identity.
Why is this correct? A. Configuring SSO SAML as a third-party IDP is necessary to integrate your external identity source with Google Cloud for authentication. E. Cloud Identity is required to federate the third-party identities into Google Cloud, acting as the directory that Cloud uses for access management. Why are the others incorrect? B. Identity Platform is used for customer identity and access management, CIAM, in applications, not for authenticating administrators to Google Cloud via Cloud. C. The question explicitly specifies using a SAML identity provider. OpenID Connect is a different authentication protocol and does not fulfill the stated requirement. D. Identity-Aware Proxy, IAP, is used to control access to web applications and VMs, not to provide third-party identity federation for cloud authentication.
You are the security admin of your company. Your development team creates multiple GCP projects under the implementation folder for several dev, staging, and production workloads. You want to prevent data exfiltration by malicious insiders or compromised code by setting up a security perimeter. However, you do not want to restrict communication between the projects. What should you do? The options are Option A, use a shared VPC to enable communication between all projects, and use firewall rules to prevent data exfiltration. Option B, create access levels in Access Context Manager to prevent data exfiltration, and use a shared VPC for communication between projects. Option C, use an infrastructure as code software tool to set up a single service perimeter and to deploy a cloud function that monitors the implementation folder via Stackdriver and Cloud Pub/Sub. When the function notices that a new project is added to the folder, it executes Terraform to add the new project to the associated perimeter. Option D, use an infrastructure as code software tool to set up 3 different service perimeters for dev, staging, and prod and to deploy a cloud function that monitors the implementation folder via Stackdriver and Cloud Pub/Sub. When the function notices that a new project is added to the folder, it executes Terraform to add the new project to the respective perimeter.
To arrive at the correct answer, we focus on the keywords: implementation folder, prevent data exfiltration, security perimeter, do not want to restrict communication between the projects.
The correct answer is option C. Use an infrastructure as code software tool to set up a single service perimeter and to deploy a cloud function that monitors the implementation folder via Stackdriver and Cloud Pub/Sub. When the function notices that a new project is added to the folder, it executes Terraform to add the new project to the associated perimeter.
Why is this correct? C. A single VPC Service Controls perimeter allows free communication between all included projects while preventing data exfiltration. Automating perimeter updates via cloud functions ensures new projects in the folder are immediately protected. Why are the others incorrect? A. Shared VPC alone does not establish a VPC Service Controls security perimeter, which is required to prevent data exfiltration to external Google APIs by compromised code. B. Access levels define who can access resources based on context, but a VPC Service Controls perimeter is required to effectively prevent data exfiltration from GCP services. D. Creating separate perimeters for dev, staging, and production would restrict communication between projects in different perimeters, violating the requirement to not restrict communication between the projects.
Last week, a company deployed a new App Engine application that writes logs to BigQuery. No other workloads are running in the project. You need to validate that all data written to BigQuery was done using the App Engine default service account. What should you do? The options are: Option A, 1. Use Cloud Logging and Filter on BigQuery Insert Jobs. 2. Click on the email address in line with the App Engine default service account in the authentication field. 3. Click Hide Matching Entries. 4. Make sure the resulting list is empty. Option B, 1. Use Cloud Logging and Filter on BigQuery Insert Jobs. 2. Click on the email address in line with the App Engine default service account in the authentication field. 3. Click Show Matching Entries. 4. Make sure the resulting list is empty. Option C, 1. In BigQuery, select the related dataset. 2. Make sure that the App Engine default service account is the only account that can write to the dataset. Option D, 1. Go to the Identity and Access Management (IAM) section of the project. 2. Validate that the App Engine default service account is the only account that has a role that can write to BigQuery.
To arrive at the correct answer, we focus on the keywords: App Engine application, writes logs to BigQuery, validate that all data written to BigQuery, App Engine default service account.
The correct answer is option A, 1. Use Cloud Logging and Filter on BigQuery Insert Jobs. 2. Click on the email address in line with the App Engine default service account in the authentication field. 3. Click Hide Matching Entries. 4. Make sure the resulting list is empty.
Why is this correct? A. Hiding entries for the App Engine default service account reveals any logs from other identities. An empty list confirms only the intended service account performed the writes. Why are the others incorrect? B. Showing matching entries only confirms the service account performed writes, but it hides other identities' actions, failing to validate it was the only account used. C. Reviewing dataset permissions only shows current authorization, not historical activity, and doesn't account for inherited project-level permissions that could grant write access. D. Checking IAM roles only identifies who currently has permission to write, not who actually performed the past write operations.
You are in charge of migrating a legacy application from your company data centers to GCP before the current maintenance contract expires. You do not know what ports the application is using and no documentation is available for you to check. You want to complete the migration without putting your environment at risk. What should you do? The options are: Option A, migrate the application into an isolated project using a lift and shift approach. Enable all internal TCP traffic using VPC firewall rules. Use VPC flow logs to determine what traffic should be allowed for the application to work properly. Option B, migrate the application into an isolated project using a lift and shift approach in a custom network. Disable all traffic within the VPC and look at the firewall logs to determine what traffic should be allowed for the application to work properly. Option C, refactor the application into a microservices architecture in a GKE cluster. Disable all traffic from outside the cluster using firewall rules. Use VPC flow logs to determine what traffic should be allowed for the application to work properly. Option D, refactor the application into a microservices architecture hosted in Cloud Functions in an isolated project. Disable all traffic from outside your project using firewall rules. Use VPC flow logs to determine what traffic should be allowed for the application to work properly.
To arrive at the correct answer, we focus on the keywords: migrating a legacy application before the current maintenance contract expires, do not know what ports the application is using, without putting your environment at risk.
The correct answer is option A, migrate the application into an isolated project using a lift and shift approach. Enable all internal TCP traffic using VPC firewall rules. Use VPC flow logs to determine what traffic should be allowed for the application to work properly.
Why is this correct? A lift and shift approach to an isolated project ensures a fast migration before the contract expires. Enabling internal traffic and using VPC flow logs securely identifies required ports without breaking the application or risking the broader environment. Why are the others incorrect? B. Disabling all traffic will break the application and prevent it from communicating, making it impossible to generate the necessary logs to discover which ports it needs. C. Refactoring into a microservices architecture on GKE is a time-consuming process that contradicts the urgent requirement to migrate before the current maintenance contract expires. D. Refactoring into Cloud Functions is overly complex and time-consuming for a legacy application, which fails to meet the time constraint of migrating before the maintenance contract expires.
A company is deploying their application on Google Cloud Platform. Company policy requires long-term data to be stored using a solution that can automatically replicate data over at least 2 geographic places. Which storage solution are they allowed to use? The options are: Option A, Cloud Bigtable. Option B, Cloud BigQuery. Option C, Compute Engine SSD Disk. Option D, Compute Engine Persistent Disk.
To arrive at the correct answer, we focus on the keywords: long-term data to be stored, automatically replicate data over at least 2 geographic places.
The correct answer is option B, Cloud BigQuery.
Why is this correct? B. BigQuery multi-region datasets automatically replicate data across multiple geographic places, regions, for high availability and durability, making it suitable for long-term storage requirements. Why are the others incorrect? A. Cloud Bigtable requires manual configuration of additional clusters in different regions to enable replication. It does not provide automatic cross-region replication by default. C. Compute Engine SSD disks are tied to a specific physical machine in a single zone and provide no automatic geographic data replication. D. Compute Engine Persistent disks can be regional, but they only replicate data across 2 zones within the same region, not across multiple geographic places.
A customer deployed an application on Compute Engine that takes advantage of the elastic nature of cloud computing. How can you work with infrastructure operations engineers to best ensure that Windows Compute Engine VMs are up to date with all the latest OS patches? The options are: Option A, build new base images when patches are available, and use a CI/CD pipeline to rebuild VMs, deploying incrementally. Option B, federate a domain controller into Compute Engine, and roll out weekly patches via Group Policy Object. Option C, Use Deployment Manager to provision updated VMs into new serving instance groups, IGs. Option D. Reboot all VMs during the weekly maintenance window and allow the startup script to download the latest patches from the internet.
To arrive at the correct answer, we focus on the keywords: elastic nature of cloud computing. Windows Compute Engine VMs are up to date with all the latest OS patches.
Correct answer is option A. Build new base images when patches are available, and use a CI/CD pipeline to rebuild VMs, deploying incrementally.
Why is this correct? A. Immutable infrastructure and CI/CD pipelines are best practices for elastic environments. Rebuilding base images and deploying incrementally ensures consistency, rapid scaling, and minimizes downtime during patch rollouts. Why are the others incorrect? B. Traditional GPO-based patching is slow and doesn't align well with elastic, immutable infrastructure principles, often leading to inconsistent states when new instances spin up. C. While Deployment Manager can provision resources, it lacks the native orchestration capabilities of a CI/CD pipeline required for automated, incremental rollouts of patched images. D. Rebooting all VMs simultaneously causes downtime. Downloading patches via startup scripts during boot is slow, unreliable, and leads to inconsistent versions across elastic VMs.